So, hello students, I welcome you all on this YouTube channel. In unit number 3, you have to study the synchronous machines, right? You have to study synchronous machines in unit number 3. So, this word synchronous has come from the word synchronization, right? And the typical Hindi meaning of this word synchronization is talmel, right? So the synchronization means, this is the typical Hindi meaning, right? Talmel. That means synchronization of what? Synchronization of rotating magnetic field with the rotating rotor. So in synchronous machine, both the rotor and the rotating magnetic field both will rotate at synchronous speed, right? Which is given by Ns is equal to 120 F by P, right? Where F is the frequency and P is the number of poles and Ns is the synchronous speed, right? So we will discuss this concept when we will discuss the operating principle, right? So you understand? Let us first discuss the construction features and construction detail of synchronous machines, right? So in synchronous machine, the rotor, you will find in any electrical machine, you will find basically two parts. One is rotating part, that is rotor, and another is a stationary part, that is a stator, right? So likewise you will get these two in synchronous machine also, right? So the rotor in synchronous machine, it has two kinds of structures, right? One is cylindrical rotor, right? And another one is salient pole rotor, right? So this figure that you're seeing, it is related to, it is basically cylindrical rotor, right? Its shape is cylindrical in nature, right? The red circle that you're seeing, it is basically showing the cylindrical rotor structure, right? While in salient pole rotor, if you see, in salient pole rotor, the rotor structure is not cylindrical, right? It is salient pole, right? The word salient means projected type, right? The word salient means projected type structure, right? That means कुछ उभरा हुआ, कुछ उठा हुआ, right? तो ये जो आप देख रहे हैं, this is the projected part, okay? This kind of rotor structure is called as salient pole rotor, or in loose terms you can call this rotor structure as dumbled shaped rotor, right? So have you seen a dumble? So this rotor structure, that is salient pole rotor structure, it matches with that, right? It's a dumbled shaped rotor. So this dumbled shaped rotor is basically salient pole rotor, right? Now see here, this outer body that you're seeing, that I have drawn with green color, right? This is basically stator, right? It is made with cast steel, right? It is a solid structure, rotor, right? The stator. Now this red one is the rotor, right? This red circle is a rotor. So these are basically slots that you're seeing. These are the slots which are cut in the periphery of the stator. In these slots, stator windings are housed, okay? ये जो slots हैं, ये stator के slots हैं. इनमें आप क्या करेंगे, इनमें आप स्टेटर वाइंडिंग डालेंगे, राइट. Okay, so these are the, let me draw, this is the stator windings, right, or stator conductors. All right, so for three-phase synchronous machine, you will have three phases. Suppose these phases are A, B and C, right? So if this is A phase, then after 120 degree phase displacement you will have phase B, then, and after further 120 phase displacement you will have phase C, right? So this is phase A. You can think of this as a forward conductor, so this is a return conductor, let me call this A dash, right? Similarly, this is B and this is return conductor, let me call this B dash. Similarly, this is C and let me call this C dash, right? Okay. Now, this is your rotor, right? So, when DC is given to rotor, it acts like a bar magnet, right? And the pole will be established on the rotor. This pole will be stationary. It is a fixed pole on rotor because DC is given, DC excitation is given, right? So suppose you have given this kind of windings, right? This is, here it is cross, it is dot, right? So when you apply right hand thumb rule on this cross and dot, right,